Today we want to take a look at the beginning of our fundamental counting principle, permutations and combinations. The fundamental counting principle is applied when you are counting the number of possibilities of multiple events happening. So let's see what we do in this case here. It says that for number 1, you're making a sandwich and get to choose one type of meat from turkey, ham, or tuna, and one type of bread from wheat, rye, sourdough, or white. How many sandwiches are possible? So if I take a look at my 3 different options for meat, I have turkey, ham, or tuna. So I can have a turkey sandwich, a ham sandwich, or a tuna sandwich. So I've got my turkey, my ham, and my tuna fish. Now each one of these, I can choose an option of 4 different types of bread. So I can have turkey on wheat, turkey on rye, turkey on sourdough, or turkey on white bread. Same thing with ham. We can have ham on wheat, ham on rye, ham on sourdough, or ham on white bread. And once again for tuna, we can have tuna on wheat, tuna on rye, tuna on sourdough, or tuna on white bread. So if I take a look at my possibilities here, well, if I count them all up, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different sandwiches. Or, using my fundamental counting principle, when I'm counting up the number of independent events that are multiples, I'm going to take my 3 options with my meat and multiply that with my 4 options of my bread to give me 12 different sandwiches. So we don't want to have to make one of these tables every single time. We can just take each of our events, how many times they happen, and multiply those together. So now looking at number 2, it says, what if we add in 4 choices of cheese? How many sandwiches can we make? So we still have our 3 choices for meat times our 4 choices for bread. And now we're going to also add in there 4 choices of cheese, so times 4. And 3 times 4 times 4 is now going to give me a total of 48 sandwiches. We can use this counting principle in multiple different ways. Let's take a look at the idea of license plates. In New York, a license plate has 3 digits followed by 3 letters. We want to take a look at 2 different cases. How many different plates are possible if both numbers and letters can be repeated? How many different plates are possible if there are no repeats? So if I take a look at this, I have 3 spots for my digits. 1, 2, 3. So I've got my 3 digits. And then that's followed by 3 letters. 1, 2, 3. Now remember that the digits start at 0 and go up to 9. So 0 through 9 actually gives me 10 possibilities for my digits. So I have 10 possibilities for the first spot in the license plate, 10 possibilities for the second, 10 possibilities for the third. Then there's 26 letters in the alphabet, so I have 26 possibilities for the first slot, 26 for the second, and 26 for the third. I want to then go ahead and multiply 10 times 10 times 10 times 26 times 26 times 26, or 10 to the third times 26 to the third. And this is going to give me 17,576,000 different license plates. Now what happens if I say there are no repeats? Well, again, I have 3 spots for my digits and 3 spots for my letters. So let's take a look at our 3 digits. Well, in the first spot, I can use any of my 10 numbers. So I have 10 possibilities. Let's say that in the first spot, we had the number 5 there. Well, now there's only 9 possibilities for the second spot. And maybe the first number was 5 and the second number was a 3. So then those 2 numbers are out, which means I only have 8 possibilities for the third spot. Same thing happens with my 3 letters. If I can't have any repeats, then in my first letter, there's 26 possibilities. Maybe my first letter was a Q. I can't have the Q again, so now there's only 25 letters to choose from for my second spot. And maybe the second letter was an X. So if the Q and the X are gone, then there's 24 spots for the third letter. So multiply your 10 times 9 times 8 times 26 times 25 times 24. And now that drops us down to 11,232,000 license plates. So in these first 3 examples, we had multiple events, and so we multiplied their total number of possible outcomes together. Let's shift our thinking now to rearranging n objects. If I want to rearrange n objects, we're going to use n factorial, which means, like we did in the last chapter, I'm going to take n times the previous numbers all the way down to 1. So if you take a look at 8 factorial, that means I take 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Now on your calculator, you have a factorial key, and that's found in your probability. So you're going to hit 8, math, scroll over to probability, and then number 4 is your factorial key. And you can see that that's going to give us 40,320. So we want to use factorials to rearrange n objects. Looking at number 4, it says if there are 9 kids playing in a baseball game, how many different batting lineups are possible? Well, if I think about this, I can create the 9 spots in the batting order. 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's say that I chose Johnny to go number 1. There were 9 kids to choose from. He's in the first spot, so now he can't bat second. So there's 8, then 7, then 6, then 5, then 4, then 3, then 2, then 1. Or I could have said, hey, I'm rearranging 9 objects. How many ways can I rearrange 9 objects? So that would be 9 factorial. And again, hit 9, math, go over to probability, and down to number 4 for your factorial key. And 9 factorial is 362,880 ways I can rearrange that lineup of 9 kids. We can do this same idea with rearranging anything, from a batting order to how people sit in a row to the letters and words. So if you look at number 5 here, we want to know how many ways can we rearrange the letters in pencils. Well, let's count. We've got 1, 2, 3, 4, 5, 6, 7 different letters to rearrange. So then I'm going to take my 7 factorial, and that's going to give us 5,040 different options. What happens if I only want to rearrange 3 of the letters? Well, let's create our 3 spots. 1, 2, 3. And if I'm choosing any of the 3 letters, well then I can choose anybody for the first spot. So there's 7. And let's say the C went there. Now I only have 6 choices for the second spot. Maybe the E is there. And then 5 choices for the third spot. So this would give me 210 ways that I can rearrange 3 of the letters in pencils. Since I'm rearranging, this leads us into permutations versus combinations. If we're going to choose R out of n objects, so we're going to choose R out of n objects here, we have 2 different ways to do that. If the order matters, then we're going to use a permutation. So that would be, for example, finishing first, second, or third place. Okay. assigning different positions to people at work. That would be a permutation. A combination is just looking for groups. The order is not important of how you chose your group. We can now redo number 6 using a permutation. How many ways can I rearrange 3 out of those 7 letters? So that would be 7 permutating 3. And again, you're going to hit the 7, go to math, scroll over to probability, and down to number 2, your permutation, then hit the 3, and that should give you 210. We want to go ahead and take a look at some of our cases here and decide whether we want to use a permutation or a combination. So number 8 says 8 runners start a race, and how many ways can first, second, and third place be awarded? Well, the order matters, so I want to use a permutation. So if I want to know how many ways can I assign those 3 positions, I'm going to take 8 permutating 3. And when we plug that into our calculator, you're going to get 336. In number 9, now there are 8 people on the track team. How many teams of 4 can be created? Well, if I'm just looking for teams of 4, order doesn't matter. It doesn't matter if I'm picked first on the team or second. I just want to create teams of 4. So now I want to go ahead and use a combination. So we're going to take 8, choose 4, because we just want to create groups of 4. So I'm going to take 8, math, go over to probability, down to number 3. So 8 choose 4 is going to give me 70. So I can create 70 different teams. Our last 2, number 10 says that 10 people serve on a committee. And how many different ways can a chairperson, a recorder, and a treasurer be chosen? Well, once again, the order matters. So I'm going to go back to a permutation. We're choosing 3 out of the 10. So I'm going to take 10 permutating 3. And again, we're using a permutation because the order is important. And this will give us 720 ways that we can pick a chairperson, a recorder, and a treasurer. And then last but not least, number 11, you are listening to music. You have time to hear only 3 songs from your playlist of 16. It doesn't matter what order I put those songs in, I just want to choose groups of 3. So we're going to take 16, choose 3, and that'll give us 560.